Okay, let's get started with our test review. There are three fundamental elements of any system: hardware, software, and databases, and we talked about the importance of it. For the test, you do need to know what a database is. It's a self-describing collection of integrated records. Why is it self-describing? We can ask a database what information it has in it, and it'll tell us. It's integrated. Those associations that you're creating are the integrated parts of the database. By turning on referential integrity, it will make sure that it's not only an integrated database, but it'll be a complete collection of information. We know now that a database can have one or many tables in it, and we know that each table has one or many attributes. That we know. How many data types did the attribute have? Only one. We also mentioned during our first class that terms like tables, we also have alternate terms. Very common. What's another name for a table? A class. In Access, you can build a database that has tables where you store the information, that you can query the data, find out what information you have, create forms for user-friendly entry, and reports, you want to format it for printing on paper. We also found out that within a table, we might have one or many attributes. And an attribute is just one piece of information that you're interested, or many pieces of information that you're interested in storing about a particular subject. How many subjects do we have in a table? Just one. For example, in the iTunes database, how many subjects are in the albums table? They're just albums. What information can be found in the genre table? A list of genres. Can I look for the artist name in the genre table? No. So a table has one subject. Attributes can also be called columns or fields, and rows can also be called records. We found out that there were three basic data types: number, text, and date or time. Now there's actually another category which is miscellaneous. So there's really four basically, I guess, miscellaneous. In addition, it's not just a number, but what type of number? Auto number, integer, double, currency, or a calculated field. We found out that we can only have one auto-numbered attribute per table. We also found that if you want to store a whole number, you use an integer, and if you want a decimal place, you use a double. Text, two basic sizes, short and long. Short is 255 characters, long is 65,000 characters. Date time is date or time, or both. If you want to store an image, like cover art, we use an attachment. And we can also have a couple of others, like a hyperlink and a yes and no, but we don't use those very often. We learned the importance that in every table it must have a primary key. And the reason we have that is a primary key is a unique identifier for each row in a table. If I have students in a table and you're student number 1, I will assign you that primary key. You'll be student number 2, you'll be student number 3, and so on. I give you each a unique number. I can look you up by number or by name. They're the same thing at the end of the day. I can use them interchangeably. Now, I will tell you, we've only used primary keys that are single attributes so far. It is possible to have a primary key with more than one attribute in it. So I could actually create a table. Let's say it's a friend table, and let's say I wanted to put the primary key as the name of the person and their phone number. I could use that as a primary key. It's called a composite key. Even though we're not going to use it, you still need to know that that exists. And I take that back because you will actually use it in week 14. You need to know this theory for the test. I can't help you in terms of the theory You just need to memorize it. I can't help you with that. You just got to know it. When you're selecting an attribute name, you've got up to 64 characters to choose from. Just like in Indiana Jones, the Temple of Doom, was it the Temple? No, it was when they're going after the knights, the chalice. Choose carefully. When they're looking for the cup of Christ and Last Crusade, that was it. They're looking for the cup of Christ. Choose wisely. What'd they choose? The people that got the jeweled one? Death. Choose wisely. One thing that we didn't talk about last time is the concept of nulls. Let's say you created a table. And let's say you actually had an album and you didn't know what the genre was yet. So you didn't put anything into the lookup. You just left it. That's what we call a null value. It's an absence of data. I don't know what it is. I haven't put it in yet. So I didn't leave it blank. Blank is not really a null. If you took a title and you click the space bar in it, you're saving blanks. If you just go past that field and don't save anything in it, that's a null. So a null is just, it's nothing. You haven't entered it yet. It may have a value or may not. You just haven't entered it. Yes, you had a question, or are you just stretching? No, I'm just stretching. Excellent. It's good for you. Yes, sir. The default value is a null. Okay. It's already a null. The default value. Until you enter data in there, it'll stay a null. It's very important in systems to understand this concept of a null because you can use it later on. We've been using the data sheet. There are two basic views to a table, the design view and the data sheet view. The design view is when I want to actually make structural changes to the table, structural changes. The data sheet is when I want to look at the actual data. And you have to be familiar with all the controls at the bottom of the data sheet. You want to move to the first record, it's the first button on the controls. If you want to move to the last record in a table, if you want to go forward or backward, if you want to create a new record, if you want to know which record you're at, you just need to be familiar with those controls. So that should come in handy. We discovered that each attribute has many properties associated with it. Each attribute has many properties. Some of the main ones: input mask, so if you want to format a phone number. Default value, so if you're creating a row in a table, you might want to default to Ontario or default to a certain type. Maybe in your albums system, you want to default to your favorite genre, which is country music for sure. Well, for some people. For me, it's pop music. You know, doesn't get much better than Britney Spears and Iggy Azalea. So that would be probably the default in my database. Would be pop music for sure. Validation rule. Maybe you want to check a value. You can use a validation rule. And we also can set fields that are required. Wouldn't be good to have a database that has null values in an album name field, would it? I've got this album table, but all the album names are null values. Shouldn't that be a required field? Yeah, I might not know the genre, but I should know the name. So, required. So you should be familiar. The other ones that aren't in there that are also important are caption. That's important. Most recently, we've been talking about associations, normalization, and lookup wizards. Every table in a database is going to be associated. They're going to have relationships. That's just the way it is. They're going to be associated. If a primary key, the purpose of that is to create a unique identifier in a row, a foreign key is used to relate tables. That's the only purpose they serve. They're there to relate tables. So let me ask you a couple questions about a foreign key. What do foreign keys get? All foreign keys get a lookup wizard. You must hear that in your nightmares, don't you? If it's not a foreign key, does it get a lookup wizard? No, no. I keep seeing all kinds of attributes that aren't foreign keys, but they have lookup wizards. No. Only foreign keys get a lookup wizard, and if it's a foreign key, it has to have one. And a foreign key, what's the purpose? It's to create the relationship. That's all it does. Follow-up question. What is the data type of a foreign key? And don't tell me lookup wizard, because lookup wizard's not a data type. What is the data type? Excellent, you were first. Bam, look at that. Number. Why is it a number? Why is a foreign key a number? Yes?
Because it's the identifier.
When you link two tables together, what you're doing is you're linking the primary key in one table to the foreign key in another table. What is the data type of a primary key? Number. So the foreign key has to be a number. Do you know how it's actually working internally when you pull up a combo box and you select a value? It's actually storing the number of the primary key of the related table. Let's say that you went to a concert and they had a coat check. And let's say there was a few friends that went, 20,000, went to a concert. And they had a coat check room. Did they take your coat and just throw it on the pile and go, see you later, pal? No, they'd throw it on the pile and say, bro. But would they do that? Or would they give you a number associated with your coat? Just work with me. They'd give you a number, wouldn't they? Then at the end of the evening, when you can barely stand, you run over and say, yo, bro, I need my coat. It's the leather one with the brown thing and then they go, give me your number. Right? Doesn't that make it easier to find stuff if you have your number? Yeah. That's all keys are. They're just a number. Oh, you're album number 5? Guess what? You're 5 then. That's all it's doing. It's just giving you that number. It's like a key, a combination. Where does the foreign key go? On the many side. Normalization. And I can't help you with this. You've got to memorize it. Normalization is the process of breaking tables apart to reduce modification anomalies. Okay? Are anomalies good or bad? Bad. That's right. We said there are different levels of normalization. If I said, yo, bro, it's a nice looking database, it's in 6th normal form, what does that also mean relative to the other normalization rules? It means it's also compliant with them as well. In business, what's the highest level that we go to? 3rd normal form. In fact, we typically only use 1st and 3rd. Why did we skip 2nd? We do that in the last class. Because if normalization is the process of breaking tables apart to reduce modification anomalies, denormalization is basically ignoring the rules or reconstituting the tables, ignoring them because of performance or practicality purposes. Let's say you're writing a test next week. In any course, in any class, you're writing a test next week. And you look at the question and you don't know what the answer is, what should you write down? Performance. You get that? Why do you have a faster processor? Performance. Hello? Why do you have 802.11ac? Performance. It runs faster. Why do you want to drive with the highest spin rate of the disk? Why do you want the most powerful laptop that money can buy? Do you get it? if you're in a test situation and you have no clue what the answer is, wing it. Say performance. It's got to be right. Well, sometimes. Why do we denormalize? Let's do this again. Why do we denormalize? That's right. What is denormalization? It's reconstituting. It's ignoring the normalization rules. Can I ignore first normal form? No. You have to normalize. Can I ignore some third normal form violations? Yeah, some. Like numbers, dates, name and address. You don't normalize those. See, isn't this fun? First normal form is violated when you have repeating groups of information. Think of an example in your head. Repeating groups of information. Song 1, Song 2, Song 3. Can't be right. If you had an employee table and they had more than one diploma, how many people have graduated kindergarten? Bingo, you've got one diploma. How many people graduated grade 8 and are here today? How many people? 2. Okay, good, 2 then. You guys stink at this. Third normal form is a transitive dependency. I may not know what one is, but if I see it, I can do something about it. If I'm looking for violations in first normal form, do I look at the design or the data sheet view? Design. If I'm looking for third normal form, I look at the data sheet. I simply go to a column, look down the column. If I see it repeat, it's a violation of third normal form, and you should think about breaking it apart. If you had a student table and eye color was one of the attributes, would that repeat, do you think, in a student table? There's only like 8 colors for eyes if you're not wearing like those funky contacts, right? There's only like 8 basic colors, of course. Gender, you're only one of 6. So, you know, right? It's going to repeat. It has to repeat. I shouldn't ask that. Multiplicity. This is how we show multiplicity on a table or on an association. 1 to many. What's the most common multiplicity that we have, or associations? 1 to many. So there's 3 basic types. 1 to 1, 1 to many, or many to many. I'm going to do a sample at the end of the review where we're going to talk about a many to many relationship. Now, here's something new. So far, has this all been repeat? Yeah. Here's a new piece of information. Junction tables. If you have 2 tables that are related, they're a many-to-many relationship, you cannot put them in a database. You have to convert them to 2 one-to-manys. We call that a junction table. If you have 2 tables that are related, many-to-many, then you have to insert a table in between. You have to. And I'm going to give you an example of when we're going to use a junction table. That's the theory behind it. If you have 2 tables that are related, that are many-to-many, you cannot stick that in a database. You must convert that to 2 one-to-many relationships. And again, I've got a sample to do that. So the bottom line in terms of normalization, Put all the attributes into a single table. Open up the design view. If you see repeating groups of information, normalize it. If it's a customer table, phone 1, phone 2, phone 3, phone 4, phone 5. If it's a recipe, ingredient 1, ingredient 2, ingredient 3, ingredient 4, ingredient 5. It's got to be pulled apart. Now I will tell you, some first normal form problems are difficult to spot. If you had a customer table and you had home phone, work phone, cell phone, fax, is that a violation of first normal form? It is. What should you do? Normalize it. Make a contact table. Very good. Fine. You look for first normal form problems. When you're done with that, you open up the data sheet. You look down the columns. If information repeats, you normalize it, or think about it at least, and then denormalize where it makes sense. The relationship window, if you make a mistake, it's very valuable. It's your documentation. It also allows you to delete relationships and recreate them. That's easy. Make sure you always enforce referential integrity. When you're in the relationship window, if you double-click on that line, just make sure that the enforcement is turned on. You can see if the infinity symbol, it's on. But you can also see it through the relationship window. Referential integrity is really important to have it turned on. It'll help you to not do stupid things with your database. You cannot delete the name of an artist if you still have albums connected to that artist. Referential integrity will do that. It will keep you from deleting artist if you still have that data in the table. I don't remember questions for cascading. It's not a big deal. Every foreign key gets a lookup wizard. The test itself, there are two portions to the test. The first portion is multiple choice and true and false, the theory component of it. Look, man, you got a 1 in 4 shot. Just take a guess, okay? Just guess. The theory portion, which is the larger portion of the test, by the way, is a practical exercise, and you'll be able to demonstrate your worldliness relative to creating databases using Access. We have a question? Yeah? This PowerPoint is on Fanch Online. In fact, you had the entire PowerPoint for the entire